a little bit. But just random chance is going to say an equal number are going to hit it on the wrong side to slow it down. I mean, odds are 50-50, right? So you can't count meteors here as anything to get excited about. So the Earth is slowing down. There's the Coriolis effect is the name of it there. That's what causes the wind patterns. And that's an interesting study which you should get into in earth science about why do we have prevailing winds. Here in Pensacola, it nearly always comes from the northwest. Other parts of the world, the wind almost always comes from a different direction. Depends on how far you're above the equator and all that stuff. So if the Earth were billions of years old, it used to be going faster. And I make a joke out of it at this point and say, well, if you think the dinosaurs lived 200 million years ago, man, I know what happened to them. They'd have been thrown off the Earth. Now, the truth of the matter is, at 200 million years ago, it probably wouldn't be real sufficient or real significant as far as the effect. In 6,000 years, it'll make a few minutes or maybe 15 minutes a day difference. You go back a few billion years, it starts to make a real difference. Now, several planets today are spinning awful fast. I believe it's Jupiter spins every 10 hours. That's a giant planet, for one thing, and it's spinning every 10 hours. Venus spins once every 443 days, or something like that. It's real slowly spinning. So different planets have different spins, and who cares? You can learn all that stuff if you like. But the Earth is slowing down in its spin for at least 3 factors, which means obviously it used to be going faster. This puts a time limit. For one thing, the textbooks are going to tell the kids the Earth is billions of years old. The Earth formed, according to them, 4.6 billion years ago. Now, at that time, the Earth would have been spinning an awful lot faster. If the Earth was spinning, say, let's just say it's spinning 20 times faster, the Earth is almost a perfect ball. What happens to a ball when you spin it real fast? Flattens out. Becomes like a frisbee, right? So if the Earth was cooling down 4.6 billion years ago and spinning lots faster, it wouldn't be round. The crust would have hardened in an egg shape. Frisbee. We wouldn't have a near perfect ball. The Earth is flattened right now. The poles are pulled in, I think it's 20 miles. It's about 20 miles wider at the equator than it is at the poles because of its spin. It's pretty heavy, you know, and just the centrifugal force going around at 1,000 miles an hour, it's pulling it out a little bit. So the Earth is spinning. Okay, the Earth is spinning is a scientific fact. How fast it was going a billion years ago, I don't know, but it does put some kind of time limit. And evolutionists don't like time limits at all. They want to have billions and billions of years. Another factor here. The Sahara Desert is the largest desert in the world. The wind almost always blows the same way because of the Coriolis effect. It happens to be in an area where the wind blows the same direction most of the time. The hot air comes off the desert and kills the trees at the edge, and that area becomes desert. The process is called desertification. That'll be a good quiz question. The process by which deserts grow. What happens is, once the area becomes desert, all the minerals leach out of the ground, and nothing will grow there again. You take pure, hot, baked sand and plant some seeds in it, there's nothing there for them to grow on. And so the soil actually gets sterilized. Nothing will grow. Sahara Desert is 1,300 miles north to south. This textbook tells the kids, notice the picture here, past Sahara Desert was pretty small, wasn't it? The yellow part. Then the pink part is the present. Possible future extension. People living right on the edge of the Sahara Desert are making the problem worse because they want to build a house or have a fire to cook their food. There's only a few trees anyway, so they cut them down. And now there's no trees. You get a good rainstorm, what happens to your soil? Washes away. Now you can't plant your crops because your topsoil's gone. So they move on further south. Because of the desertification process and because of people and their poor farming practice, Sahara Desert right now is growing 4 miles a year. At 4 miles in a year, at 100 years, that's a problem. What used to be good, beautiful farmland is now desert in a hurry. What are all these people going to do? Keep moving. Where? onto somebody else's property. Going to create a problem, right? Regardless of the human suffering and tragedy going on over there, and it is a tragedy, because of this process, this desert is growing. But even if no people lived there, the desert would still grow because of the hot air killing the trees and grass at the edge, and the soil gets sterilized. They did quite a study on this and said the Sahara Desert is about 4,000 years old. Actually, now with satellites, they can go up and fly over with the satellites and look down and see where old rivers used to be. Riverbeds all over the Sahara. Used to be a lush tropical forest. Sahara Desert's about 4,000 years old. Now that brings up an interesting question. If the Earth is billions of years old, why don't we have a bigger desert someplace? Why do you think the largest desert in the world is less than 4,000 years old? You have a theory about that, Dan? Yeah, me too. You see, about 6,000 years ago, God made everything. 4,400 years ago, there was a flood. In this flood, everything drowned, of course, and it's pretty hard to have a desert under a flood. And so the biggest desert in the world should be less than 4,400 years old, if the Bible is correct. Oh, and it is. Well, what do you know? So here we have an interesting correlation that the Bible date is correct. Roughly 4,400 years ago, a worldwide flood. When they drill down into the ground, they hit oil. The oil's under pressure up to, I don't know, I've not heard of any exceeding this, but up to 20,000 pounds per square inch of pressure. That oil wants out of there. How many have ever seen the movies where they drill down and hit a gusher? The oil comes squirting up out of the ground, okay? Not all oil wells are that way, believe me, but some are. Incredible pressure. When we lived in Texas, we had a lot of guys that worked in our church that worked in the oil field. And being a science teacher, I was always curious about the oil, and how do they do this? And I would go out and visit the oil wells and, watch them drill this stuff. They drill down about 1,000 feet, a big 12-inch hole. That's quite a post hole digger, by the way, they've got for that. They dig down 1,000 feet. Then they put a special donut down there called a blowout preventer. And they run wires up to the top to a switch. Then they go and they drill through the middle of their blowout preventer. They drill a 4 or 6-inch hole the rest of the way down. If they hit a high pressure pocket, the switch automatically trips to close it off. Because in the early days, they would drill down for gas or oil. They hit one of these high pressure pockets, and it comes shooting up out of the ground so hard, it eats the side of the hole away, and the hole gets bigger and bigger and bigger from all this oil squirting up, and pretty soon everything falls in the hole. People, buildings, tractors, everything. There was one in East Texas, I believe, where it ate up an entire acre, collapsed. Killed a bunch of people. Everything just swallowed up into the ground. It wasted a lot of oil, too. Blows all over the place. So now they prevent that with what's called a blowout preventer. Who cares, right? The fact is, oil wells often have incredible pressure down there. Now, the guys who deal with this have to have special tubing, special valves, special equipment. They're ready to handle incredible pressure. The scientists who studied the rocks on top of the oil say this rock can't handle the pressure for more than about 10,000 years. The pressure should have leaked off. What would eventually happen is the rock's going to crack. When I was in Texas, in the middle of oil patch in Longview, Texas, we had guys, I'd go soul winning, and they would say, oh, I do frack jobs for a living. So you do what? He said, yeah, we drill down, we pump the oil out of the ground. Now you got to figure way down there, it's like a big sponge, only hard rock sponge, a sandstone sponge. You pump out the oil, it soaks into the hole, you pump out some more, and you got to wait till more oil soaks in. Oil's not in a hurry to get to the hole, just gravity fed, okay, or under pressure. But after a few years, you've pumped out an area about as far as you can get. Now your oil well quits pumping. Nothing down there to pump anymore. So they pull the pump out, pull the well out, pull the pipe out. They pour in a bunch of liquid nitrogen, and then quick pour a bunch of concrete in the hole to fill the hole in, maybe 100 feet of solid concrete. The concrete hardens, the nitrogen is hot, turns to gas, expands, and it creates so much pressure, it cracks the rock underground. And cracks go shooting out for hundreds of yards in all directions. It's an underground explosion is what it is. And they're fracturing the ground out, from here to PCA. Now the oil over there has got a crack to flow through, so it flows into your hole.